So in the previous class, actually we go through the model that is called COCOMO, right? This is the model where we actually estimate the development effort, development effort, from the estimate that is called KD log. That means thousands of delivers of lines of code. So in that particular case, there are 15 multiplying factor. That means what should be the cost of the project that we should actually find from that. And the corresponding formula for initial estimate for effort, and that is EI A star KD log to the power B. That is the corresponding formula. And this particular values of constant that will actually depends on the project type. Then the project are categorized into three sectors. One is called organic sector, one is called embedded sector, one is called semi-detached sector. So in case of organic sector, that means an organizations had considerable experiments and experience and requirement, whatever be the thing. We are not bothered like that, because in your questions either you have to identify that your project will be on, either it should be in organic or embedded or semi-detached, either it is in given, or either by using this simple example you can find that whether this your project is belongs to organic or embedded or semi-detached. Because depending on this organic, semi embedded and semi detached, the value of the constant is dependent on that. That means the constant value A and the constant value B is dependent on the type of project, and these values are fixed. That means for organic the value of A is this, B is this, for semi detached this, and like that. So like that. That means the questions may be coming like that. We are considering a system of you can say office automation. We are considering a system of office automation is to be designed, and from this requirement it follows that there are four major modules. The four major modules is: one is the data entry, one is the data update, one is the query, one is the report generations, right? So you have to find the size of different modules, size of the different modules that are given: data entry, data update, query, reports. That is a given. KD log, that means thousands of lines of code. This is a unit, right? Unit of measurement of the line of code. So the questions comes like that. From requirement, it follows that the project falls in the organic category. If it falls in the organic category, then the value of A is 3.2 and value of B is 1.05, and you are just using the simple formula. Estimate, initial estimate is A multiplied by, this is the total KD log to the power B, and the value of A and value of B are determined from the table, where it is given that you are dealing with the organic, the project falls under organic, and by using that you can just find the initial estimate of your particular project. So this is a one type of problem. It may be somehow something something problematic, but we will solve a problem from the COCOMO, which is coming in ISRO, right? Then Sandeep, I am coming to your problem, right? So uh, if the problem is given like that, which is coming in ISRO, the questions that is given like that: a company needs to develop a digital signal digital signal processing software for one of its newest one of its newest invention one of its newest inventions. The software the software is expected the software is expected to have 20,000 lines of code. The company needs to determine needs to determine the effort in percent month, needs to determine the effort in percent month needed to develop this software, needed to develop this software using the basic COCOMO model, using the basic COCOMO model. The multiplicative factor, the multiplicative factor for this model is given as 2.2 for the software development, on embedded system, on the embedded system, while the exponential factor, factor is given as 1.5. What is the estimated? What is the estimated effort in percent month? These are the options that are given. These are the corresponding options. So in that particular questions, they are using basic COCOMO models, right? So what they are given in that options A. Okay, let's see. So in that particular case, amra ki dekhlam, what we see, the initial estimate, the formula is A multiplied by this is KD log to the power B. That is a simple formula. So you know, in that particular questions, it is given that this number of line of code, you know, number of line of code is 20,000 lines of code, right? So that means, you know, line of code that is 20,000. So that means if we convert in KD log, you have to divide it by 1,000. That means 20, right? Because line of code is 20,000, KD log means thousands lines of code. So if you divide it by thousands, you will get 20. That means that particular value is 20. And in your questions, you just see that is given the multiplicative factor for this model is given as 2.2, and the exponential factor that is given as 1.5. Multiplicative factor means the value of A that is given as 2.2. The exponential factor, that means value of B, is given as 1.5. You just put it in the formula and you will get the answer. That type of questions are given in that particular case. That means this is 2.2 and KD log is 20.1.5. If you solve it, you will get the answer. This is. I think it makes sense. বোঝা গেছে?
হ্যাঁ স্যার বোঝা গেছে।
Okay. Tomal, Neha, Raksha.
Yes, sir.
Okay. Now the second question that has already sent by Sandeep, the question is like that, that is also given in ISRO. The question is like that. The question that is given like that, a company a company needs to you know develop needs to develop a strategy for software product software product development, for which it has a it has a choice of two programming language L1 and L2. The number lines of code, that means the LOC developed using L2 is estimated. That means second programming language, if we develop the project with L2, then the number of line of code developed using L2 is estimated to be to be twice of the line of code developed with L1 developed with L1. The product will have to be maintained for 5 years. The product will have to be maintained for 5 years. So various you know various parameters for the company are given in the table below. What are the parameters that are given? The question is, I think, here the parameters, and it is given for language L1 and for language L2. So what are the parameters? Man years needed for development. Line of code 10,000. For language, this is also 10. I mean, a language dev, you will take 10,000, and development development cost uh, that is given, and this is given. This is the development cost. And maintenance time, it is also given. This is for 5 years, and this is for also 5 years, because that is given. And cost of maintenance per year, that will cost 1 lakh per year, that is cost 50,000. So that other thing are given. So the question is, total cost of the project includes cost of the development and maintenance. So what you have to find? You have to find the cost of the project includes cost of development and maintenance. What is the line of code of L1 for which of the cost of the project using L1 is equal to the cost of the project using L2. আমাকে বার করতে বলেছে what is the LOC of L1, for which the cost of the project using L1 is equal to the cost of the project using L2. That means the thing is that what should be the line of code of L1 such that the cost of the project using L1 that should be equals to the cost of the project using L2. And these are the different options that are given. So now the question is that it is given that whatever be the line of code for L1, the line of code for L2 is double, because in the questions that is given. If you see the questions, then first of all it is written here that you know mm, the line of code developed using L2 is estimated to be twice of the line of code developed with L1. That is already been written. So, and it is also given that the cost of the project of using L1 that should be equals to the cost of the project using L2. That is also given, right? Because you have to find this is the cost of the project using L1 that is equals to the cost of the project using L2. That is also given. And you have to consider the development and maintenance cost, right? Development cost and maintenance cost that you should have to consider. So now we will start. So that are the thing. That means if we take let the this for L1 is x, then this for L2 is 2x, say, because that is given. And also it is given that cost of project using L1 that should be equals to cost of project using L2. And of course the cost of the project that includes, that means the development cost, development cost of L1 plus maintenance cost L1 that should be equals to development cost of L2 plus maintenance cost of L2. That's true. So now we have to find the development cost. So it is given that development cost, 10,000 lines, like LOC by 10,000. That means if I am taking the LOC for L1 is X, so this is X by 10,000, and development cost is 10 lakhs, so that should be multiplied by this, and maintenance cost is 1 lakh per year, so this is a 5 years. So what is the development cost? This is X by 10,000 multiplied by 10 lakhs. Uh, if I am wrong, then you just tell. And 5 years is maintenance, and for each year the maintenance cost is 1 lakh. 2 3 1 lakh. Similarly, development for L2, the number of line of code is 2x, and it is also same because you just see LOC by 10,000, and this is 75000, 7 lakh and 50,000. So that means is equals to 2x by in the questions it is given. Sandeep, it is 10,000 everywhere, right?
Yes, sir.
Okay. So this is 10,000 multiplied by 750000, and the maintenance cost 5 and 50,000. That is a simple thing. Then from this you have to find the value of x. দেখো বার করে দেখো কত আসছে, এই তো ইকুয়েশনস না?
Sir, 5,000.
Yeah, so 5,000. So the thing is 5,000. So answer is 5,000. I think that part is clear also, and that type of questions are coming since so ISRO containing this type of questions, so not an issue. We can solve this type of questions. Okay, so this is the different types of questions. You see that that will come from the previous model that is called COCOMO, right? Okay, just a minute. So if there are anything, otherwise we will start the next. This is called cyclometry complexity. That is the next thing, and that is one of the easiest thing uh, of this particular, you know, chapter, software engineering. So let's see that whether we find any other questions from the COCOMO or this psychometric concept. Just a minute. Okay. তো সন্দীপ, আর কোনো ইয়ারে কি তুমি দেখেছো এসেছে?
নিলিটে ওই সেম কোশ্চেনটা, এই কোশ্চেনটা রিপিট করেছে। আর সাইক্লোমেট্রিকে আপনার মানে আমার কাছে অনেকগুলো কোশ্চেন আছে। ওই সলিউশনস আড্ডা বলে একটা ওয়েবসাইট আছে স্যার, ওইখানে সফটওয়্যার ইঞ্জিনিয়ারিং এ যান, দেখুন প্রচুর কোশ্চেন আছে। মানে
আচ্ছা
গেট আর ইসরোর মানে প্রচুর কোশ্চেন দিয়েছে। নিলিটেরও আছে, ইউজিসি নেটেরও আছে স্যার।
আচ্ছা, ঠিক আছে, তুমি লিঙ্কটা একটু আমায় পাঠিয়ে দিও পরে, ঠিক আছে? তাহলে কোশ্চেন্সগুলো একটু সলভ করানো যাবে ওখান থেকে। আর যদি তুমি পাও কিছু কোশ্চেন্স তাহলে আমায় পাঠিও, রাইট? মানে যেটা এসেছে ইসরোতে বলো বা ডিআরডিওতে বলো, কারণ গেটের কোশ্চেন্স তো এখন আর সিলেবাসে নেই, বাট ইসরোতে আছে যখন, তাহলে যখন পড়ছি তখন এগুলো অ্যাট দ্য টাইম সলভ করে নিলে দ্যাট উইল বি বেটার। বাট এই কোশ্চেন্সগুলো তো প্রত্যেক বছর আছে না, তাই জন্য নাম্বার অফ কোশ্চেন্স কম আছে। হোয়াট এভার বি দ্য থিং, so today we start the thing that is called, you know, psychrometric complexity, or you can also say that that is called, you know, the first thing that you need to understand, that is the control flow graph. That is called control flow graph, CFG. That is control flow graph. So what is control flow graph? That particular control flow graph actually describes how the control flows through the program. We'll understand that thing. In other words, you can say we can define a control flow graph as the following. That means that will give you the sequence in which different instructions of a program get executed, or you can say that particular graph that actually describes the sequence in which the different instructions of a program get executed. That is the first section. That means, say, just I am writing a particular sequence like a equals to 5, and say b equals to a multiplied by 2 minus 1. That means we will understand that after getting the value of A, then only B can execute. That means the flow is one should be executed first and then second. So I can draw the graph like that. If say the equations or the code is given like that, if A is greater than B, then say C is equals to 3, else C equals to 5, and then C equals to C multiplied by C. That means this is the first conditions that you need to check. If the first conditions, is true, then C equals to 3. That means the second conditions will be executed. But if this condition is false, then also you can say these conditions, this execution. That means 2 and 3 are not they are independent. They are not dependent on each other. And after execution of this, you know, the statement 4 is been executed. So this type of diagram you can think that is called control flow graph. Or you can say, if I am written like that, while A is greater than B, say B equals to B minus 1, say B equals to B multiplied by A, and say C is equals to A plus B. So what we can say, when we execute the instructions 1, within this, B will be decremented, and then B will be multiplied with A, and again it will be checked. So that means from 3 I can go to 1. And as well as, if the while condition is false, that means it is not true, it directly go to the statement 4. So I can draw the graph like that. So these are the examples, right? So what we will get, that this CFG, that means this control flow graph, that is a directed graph consisting of a set of nodes and edges, right? So and that particular control flow graph, that will be helpful for designing, you can say, mm, designing the cyclometric complexity. That means this particular CFG. So this particular CFG, that is a, you can say, directed graph. That is nothing but a directed graph consisting of a set of nodes, and edges, such that such that each node each node n, which is belongs to n, that particular thing corresponds to corresponds to a unique program program statement, and an edge exists between two nodes, an edge that exists between two nodes, if control can transfer from one node to the other, if the control is transferred from one node to the other. So from that, what we can say, let's I'm just giving you a program. You just try to draw it, that whether it can be possible for you to draw it. Say integer, I am just computing GCD, right? Say integer x, integer y, and the first line, this is the first node, while x is not equals to y, then if x is greater than y, then x equals to x minus y, else y is equals to y minus x. That means this is 3, this is 4, this is 5. While loop is completed, 6 is written, x, that's all. That means there are 6 nodes are there, and you have to just calculate it how can be possible. So just try to draw it, then we will uh, draw the thing. So what will happen? This is the first node, first statement while is executed. If the while condition is true, then it goes to the if. This is second, and if means if condition is either true. If it is a true, then x equals to x minus y. If it is a false, y equals to y minus x. So this is number 3 statement, and there is number 4 statement, and that will meet right at a number 5. That means it is a complete. And it may be possible that this is a while loop, that means it will be evaluated until and unless this particular condition is false. So that means this goes to there, and it may be possible that the while conditions in the first step that will fall, then it will false, then it will return x. So that means it will be like that. Okay, so that will happening like that. This is nothing but the control flow diagram of a particular example. Now the thing is that we have to know something that is called linearly independent set of path. Linearly independent set of path, that is called linearly independent. Linearly independent set of paths, and or you can say that is named as a basis path set. Linearly independent set of paths or basis path sets. So when we called a particular path, path means I think there should be like a path 1, 2, 3, 5. That should be a path, or 1, 2, 4, 5. That is also another path. That is a path. So what should be the definitions? That means a set of paths, a set of paths for a given problem is called linearly independent. Linearly independent set of paths, or the set of basis path, or simply the basis set. Basis set. If each path in the set introduces at least one new edge, one new edge that is not included, that is not included in any other path, in any other path in the set. We will see by example. তার মানে there should be different paths, but each path in the set that introduces at least one new edge that is not included in any other path in the set, right? So there is also alternate definitions of linearly independent set of paths. Actually, if we say about an alternate native definition, and that should be done by the Maccabee, because this is the complexity, cyclometric complexity is done by Maccabee. So what is this? That definition, the meaning is same, but the definitions is different. So if a set of paths is linearly independent, if the set of paths is linearly independent of each other, then no path in the set can be obtained through any linear operations, any linear operations, that is addition, or you can say subtractions on the other parts, on the other parts in the set. বাবু একটা সেট কন্টেইন করছে a set of paths that is linearly independent of each other, then no path in the set, no path in the set can be obtained through any linear operations on the other path in the set. Other path on the set এর উপর, মানে সেটাকে, মানে আমি কোনো পাথ, এর মানেটা কিন্তু একই, যে আমি if we got a path, then what will happen, each path should be taken as an independent path if and only if every time a new edge, a new vertices will be included. That means we have to introduce at least one new edge that is not included in any other path in the set. That is same but in alternative definitions that is given by the Maccabee, and from that actually the thing that is came, that is Maccabee's cyclometric complexity matrix. That is the questions that will always been coming in your, as well as the semester examinations, as well as there is a formula by which you have to solve the problem. The formula is very simple, but you can at least solve the problem. Complexity matrix. So Maccabee cyclometry complexity matrix. So that Maccabee cyclometry complexity actually that defines an upper bound, that defines an upper bound on the number of independent paths, that will give you the defines an upper bound on the number of independent path in a program. And there are different methods by which you can actually calculate the complexity. The thing is that complexity actually used for determining by the number of independent paths through a program. So you know about the independent path. What do you mean by that? Then we will see an example and we will see that how it can be evaluated. So the thing is like that. It may be possible that a flowchart is given. So the thing is that, say the flowchart is given like that. Flowchart is given like that. Say in the questions is maybe a flowchart is given, and this is from that say this type of flowchart is given. This is the corresponding flowchart. This is 4. Say this is 5. And from that it will be connected like that. This is the corresponding just a flowchart. আমাদের ওখানে প্রোগ্রাম দেওয়া থাকতে পারে বা আমাদের কি দেওয়া থাকতে পারে, ডিরেক্ট এরকম ফ্লোচার্ট দেওয়া থাকতে পারে। এখন ফ্লোচার্ট যদি এরকম হয় 1 2 3 বুঝতেই পারছো, and of course that are given like that. সো এটাকে আমাকে কনভার্ট করতে পারি এই ফ্লোচার্টকে আমরা ইন রেসপেক্ট অফ সাইক্লোমেট্রিক কমপ্লেক্সিটিতে। তো আর এরকম নাম্বার অফ নোটস আছে, রাইট? নাম্বার অফ নোটস যেহেতু আছে তাই নোটসে আমায় কনভার্ট করতে হবে। আমি জাস্ট কনভার্সনটা এই পাশাপাশি করছি, জাস্ট একটুখানি দেখো, এগুলো খুব একটা দ্যাট ইজ নট টু ডিফিকাল্ট টু আন্ডারস্ট্যান্ড দ্য থিং। সো দিস ইজ দ্য number of nodes, right? And say this is node number 11. You just see that 2 and 3, that means this control flow 2 and 3 are the similar thing. So what we can say, I can make a note and just write 2 and 3. And of course from 2 and 3, from 3 there are two parts. One is going through 6. So this is a 6, and 6 to either that should go to 7 or either that should go to 8, and either they should come to the 9. And this is a 4 5. You just see 4 5 is the same sequence. That means after 4 there should be 5. So I can take this 4 5 as a single node, and they all are meted at 10, right? And this 10 is back to 1. So this is the corresponding, if we say this is the corresponding, you can draw a flow chart but with respect to the control flow graph, right? So this is the control flow graph that we draw from a flow chart. That may be the questions, because we already know how you can convert a program into control flow graph. In that case, a flowchart is converted into a control flow graph. Now, what are the different paths? I'm just writing here paths. The last 1 to 11, that may be a path. Path 1, path 2, it can be, this is a 1 to 11. This is 1, 2, then 3, 4, 5, then 10, then 1, then 11. I am coming from 1 to 11, right? And these are the path. In that part we introduce different nodes, so that's why that can be treated as an independent node. Say path 3, this is 1, this is 2, this is 3, this is 6, this is 8, this is 9, this is 10, this is 1, and this is 11. Also that part are different from path 2 because I am including extra node, right? 6, 8, 9, that is not included in the previous path, so that is also independent path. Say path 4, 1, 2, 3, 6, 7, 9, 10, 1, 11. In that path I am including this extra node which is not included in any other independent path. So there are, you can say there are 4 independent paths, because now if you can draw any path that will include, that will not include any extra edges, right? But path 1 to path 2 we are including extra edges. From path 2 to path 3 we are including extra edges. From path 3 to path 4 we are including extra edges. So that are all called, independent path. That all are called independent path. That what we draw. I am just drawing. I am just finding this particular independent path, just calculating manually, right? And the thing is that that is very difficult, because in that particular case the graph is very small, so that's why I'm just going through it. But you just see, ideally a program is converted into a control flow graph, and this graph can be big and big. If there are 20 nodes, not more than that, then that is very difficult to find the independent path. But what the cyclometry complexity graph, that will give you the maximum number of independent paths. That will give you the maximum number of independent paths. That is the thing. So what is the maximum number of independent? Because here the number of independent path is 4. You cannot draw more than 4 paths, right? So the thing is that it is a directed path. So this cyclometry complexity actually gives you a formula for finding the upper bound of the independent path. In that case, by analyzing this, there are maximum 4 independent paths are possible. But the thing is that uh, how can we mathematically found this? And that is done by the Maccabee, right? So the Maccabee cyclometry complexity, it said that he actually find the cyclometric complexity in a different ways. The first way, that is the very much popular way, that if the total number of vertices, that means, so we have a given a control flow graph, given a control flow graph G of a program, the cyclometric complexity, Vg, that can be computed as, the formula is Vg is equals to E minus N plus 2. That is the corresponding formula. What is E? E is nothing but the number of edges, N is the number of nodes, N is the number of nodes of the control flow graph. This E is the number of edges in the control flow graph. So in that particular graph, if we want to find the number of independent, what are the number of nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here the number of nodes are 8, I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And number of edges, you just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So if we just put in the formula, so what should be the Vg? Vg is nothing but E number of edges you can find, that is 11 minus 9 plus 2, that will give you 4. You just see what we find manually, that number of independent path, that is written as a 4. In that case, by using this cyclometric complexity formula, we will get the same value. But just calculating the number of edges, number of nodes plus 2. Okay. And there is also an alternative way, that is the way number 1. Also you can calculate by using way number 2. The psychrometric complexity can be written as total number of non-overlapping bounded area plus 1. Non-overlapping bounded area plus 1. That means if we see in the, just a minute, if we see in the diagram, what we will see, that is, you can say that particular thing is the region, right? This particular thing, I'm saying this bounded thing, that means 1 2 3 4 5 10, this can be written as region 1, that is a bounded. This is the region 2, 2 3, this is the region 3, and there are three regions, that means three bounded areas, and another one is the outside, right?
স্যার
Yes.
স্যার বলছি একবার তো ভিজিটা বার করলাম, তাহলে আবার কিসের রেসপেক্টে বার করছেন?
এটা ভিজিটা ডিফারেন্ট ডিফারেন্ট ওয়েতে, মানে সাইক্লোমেট্রিক কমপ্লেক্সিটিতে। ধরো তোমার অঙ্কে কিরকম দেবে বলতো, ধরো ভার্টিসেস এজেস না দিয়ে নাম্বার অফ রিজিয়নস দিয়ে দিল, তখনও তো বার করতে পারো। তাই জন্য এগুলো হচ্ছে একই জিনিসই বার করার ডিফারেন্ট ফর্মুলাস, আর কিছু না। মানে আমরা
আচ্ছা।
নর্মালি এইভাবে ক্যালকুলেট করে 4 বার করতে পারি, আদারওয়াইজ ওই যেটা ফর্মুলা দেখলাম নাম্বার অফ এজেস মাইনাস নাম্বার অফ ভার্টিসেস প্লাস 2 দিয়ে, সেটা দিয়েও আমরা সাইক্লোমেট্রিক কমপ্লেক্সিটি একই জিনিস বার করতে পারি। আবার এই রিজিয়নস দিয়েও আমরা উই আর ফাইন্ডিং দ্য সেম থিং, নাম্বার
আচ্ছা
অফ
স্যার,
রিজিয়নস।
স্যার অ্যান্সারটা তো সেম আসবে।
একদম সেমই তো আসছে। এখানে দেখো 4টি ইন্ডিপেন্ডেন্ট পাথ ছিল, আমরা
হ্যাঁ
সাইক্লোমেট্রিক কমপ্লেক্সিটি দেখি, দেখো অ্যান্সারও এখানে 4 এসেছে, এ দেখো এটা তো 4 এসেছে, রাইট?
হ্যাঁ
আর এখানেও দেখো নাম্বার অফ নন ওভারল্যাপিং বাউন্ডেড এরিয়া কত, দ্যাট ইজ 3 প্লাস 1,
3, হ্যাঁ
দ্যাট ইজ অলসো গিভস ইউ 4।
4।
বুঝতে পেরেছো? তার মানে
হ্যাঁ
আমরা এই 4টে ভাবেই বার করতে পারি, সেটাই বোঝানোর উদ্দেশ্য। ওই মানে 3টে ভাবেই আমরা এইভাবে সাইক্লোমেট্রিক কমপ্লেক্সিটি আমরা বার করতে পারি। ক্লিয়ার?
আচ্ছা, ওকে স্যার।
So that is also called like a region. That means you can say the total number of non-overlapping region, or you can say that number of regions of the flow graph corresponding to cyclomatic, complexity. That is also called cyclomatic complexity. And what is regions? That means areas bounded by nodes and edges are called regions. And when counting regions, we include the area outside the graph and count it as a region. And that's why আমরা এখানে I am adding +1 here, I am adding +1 due to this reason. So that's all. That is nothing but a psychometric complexity, and I think that particular thing is very much understandable, because that is not a big issue for understanding this particular thing, because that is very simple. And you can solve the problem from the website, and it will be better that if some of the problems যদি আটকায়, then we will solve it, right? Now, so আশা করি এটা বোঝা গেছে। and the next thing is that is one of the important thing as well, as that is called DFD. That is called DFD. So that is also in your next topic, that is called DFD, data flow diagram. So let's start that particular thing. Just a minute. So the first thing is that this is called data flow diagrams, or you can say DFDs, data flow diagrams. So DFD is also called bubble chart, right? And that is a simple graphical representations that can be used to represent a system in terms of input data to the system and various processing carried out on those data. That means Dharo, when you are trying to develop a project is a very big idea. But when you are dealing with the management team, or if you are dealing with the class, what will happen? You have to first draw some diagram, because they are not, the client will not understand the corresponding details of the code. What do you understand? You just understand the corresponding concept. That means if it will be represented with respect to some diagram, that will always be beneficial for the client as well as the system provider, that they both understand the thing. So that is the simple implementations of the project in terms of you know some there should be some notations. By using some notations, you are describing your project to a layman. That is the first target of data flow diagram. That means actually in industry, what will happen in our uh, you know in our project, in our classroom project, like when you have to write a program, what we have to do? You have to just know the algorithm, you can just start writing the code, and after writing you are just in. But that will be happening when you are writing a code for 50 or 100 lines. But a project is not like that. A project that will be containing more than 1 lakh, 2 lakh, 3 lakhs lines of codes, and there are lots of people are involved in a single project. And so there should be some step by step procedure. You are just start writing the code, and it will not run, then it will very much difficult, because it will take 4 or 3 months to run a project like that. So what will happen? Before starting a project, everybody will sit and draw a diagram. So by using, just explaining the diagram, whether that should be feasible, if we start implementing, that also should be known to both of the client and as well as the system provider. So that's why this type of software engineering subjects came, right? And that is also been helpful in the today's industry. That means before starting a project, you have to do the analysis of the project, whether the project will be completed within a some days, or what should be the manpower, what should be the maintenance cost, all those stuff that should be analyzed before the project has been delivered, right? Or you just start coding. So there are step by step, and by DFD is nothing but a simple graphical representations, right? By seeing the DFD, we just we should know that what should be the different processing carrying out on the data, what should be the output generated by the system. Uh, that should be, you should understand. So you can say that particular DFD, that is also, you can say, known as the bubble chart. This is also known as the bubble chart. That is a simple graphical simple graphical formalism that you know can be used to represent used to represent a system in terms of the input data to the system, and various processing that actually carried out on those data, various processing, and the output data are generated by the system, and the output data generated by the system. The main reason why the DFD technique is so popular, probably because of the fact that the DFD is a very simple formalism and it is very simple to understand and use. So of course DFD that should use very limited number of primitive symbols, very number of primitive symbols, and you know that uh, that human mind is such that it can easily understand any hierarchical model of a system. And because in a hierarchical model, starting with a very abstract model of a system, various details of the system are slowly introduced to different levels of hierarchy. So that's why you can say DFD is also been popular, because the human mind itself is very efficient to remember the hierarchical system. We are starting with a very simple thing, and then day by day it makes complicated. So what are the basic symbols we are using in DFD? This particular symbol is used to express external. These are used to express external entity. By using circle, that will define process. This is used for storing the data. This is a data store. By using this arrow, this is nothing but data flow, and this is nothing but a by showing the output. So these are the 5 symbols that we are using in DFT. So the first thing is the process or function symbol. So by using circle, what is the meaning of that? What do you mean by process? So first one is the function symbol. So what is function symbol? That means a function in that particular case is represented using a circle, and this symbol is called process or a bubbles. This symbol is process or bubble. That's why this is named as a bubble diagram. Bubbles that are annotated with the names of the corresponding functions. So what are the things? There are some external entity symbol. There are some external entity symbol. So what is external entity? External entity is like you can say a librarian. A librarian can be treated as an external entity, right? So um, you can say, uh, and that should be represented by the rectangle. That should be represented by the rectangle. That means external entities are essentially those physical entity external to the software system. That means which interact with the system by just inputting the data to the system, or by you can say consuming the data produced by the system, right? So external entities like that, meaning they are outside the system, but they either supply input data or use the system's output. That means external entity that supply data into a system are called sources, and entities that are uh, you know mm, that use system data are called sink. Okay, so
স্যার এন্টিটিটা কি একটি লাইব্রেরি ফাংশন?
লাইব্রেরি ফাংশন নয়, মানে আমি এক্সাম্পল দিলাম লাইব্রেরিয়ান, রাইট? একটা লাইব্রেরি মেম্বার এমনি বলতে পারি। মানে একটা এক্সাম্পল হচ্ছে লাইব্রেরিয়ান। ধরো লাইব্রেরিটা কি, ধরো আমি বললাম একটা সিস্টেমে সেটা একটা এক্সটার্নাল এন্টিটি হিসেবে ট্রিট করছে, তার কারণ লাইব্রেরি থেকে তুমি বুক নিচ্ছ, সেই বুকটা তোমার ধরো একটা নলেজ গ্যাদার করতে কাজে লাগছে, বাট দ্য থিং ইজ নট, ওই যে বললাম এটা ডিরেক্টলি তোমার সিস্টেমে ইনভলভ নয়, এরকম ব্যাপারটা। মানে কোনো কিছু যেটা ডিরেক্টলি তোমার সিস্টেমে ইনভলভমেন্ট নেই, বাট উই আর জাস্ট টেকিং দ্য ডেটা ফ্রম দিস পার্টিকুলার এন্টিটি, অ্যান্ড ইফ আই এম জেনারেটিং সাম আউটপুট, সেই আউটপুটটা কাজে লাগছে তার, তাকে বলা হচ্ছে এক্সটার্নাল এন্টিটি, নাথিং বাট। দ্যাট মিনস দে আর আউটসাইড, that means they are, you can say, outside the system, but they either, you can say, supply input data, either supply input data or use the system output, or use the system output. So external entities, external entities that supply data into a system are called sources, and entities that are, that means entities that uses system data are called sink, that are called sources and that are called sinks. That means customer, you can say customer, you can say about the customer. Customer, I am giving some input, and as well as what should be the output of that, that would be taken by the also customer. So this type of external entities. So another,
सर
हाँ,
सर एक्सटर्नल एंटिटी को हम लोग वो बोल सकते हैं, मतलब जो सॉफ्टवेयर को जो यूज़ कर रहे हैं, जैसे लाइब्रेरियन एक लाइब्रेरी मैनेजमेंट सिस्टम को यूज़ कर रहा है, तो सर लाइब्रेरियन एक एक्सटर्नल एंटिटी।
yes, yes, librarian is an external entity when we are using library management system, right? Because
ओके सर।
लाइब्रेरियन क्या करता है, जो बुक का इनपुट सिस्टम में देता
हाँ,
है,
इनपुट प्रोवाइड करता है।
so that's why this is called an external entity.
ओके सर।
And there are also the thing that is called data flow, that means data flow symbol. So what is data flow symbol? That is nothing but a directed arc or an arrow that is used, you know, as a data flow symbol, that is used as a data flow symbol. That means a data flow symbol that will represent the data flow that will occurring between two processes or between an external entity and process. So there are different types of thing that can be happen. That means flow of data and flow of data. So that flow of data can take place. The first thing you can say, between two processes, or you can say from a data store to a process, or from a process to a data store, from a source to a process, or from a process to a sink, from a process to a sink. So and stores, that particular stores that are the passive and cannot have data flow between them. That means the store cannot, you know uh, flow the data between themselves. So these stores, that means data store that are, passive, and that actually cannot have data flows between them. That is the data flow symbol. And what are the thing? This is the data store. That means, what is data store? You can say, because what are the different things that we write there? One is the external entity, one is the process, one is the data store. So what is data store? If we just write what is data store, so you can say that a data store is represented by using two parallel lines. You just see it represent logical file. That means a data store symbol can represent either a data structure or a physical file on disk. That means that particular data store symbol can represent can represent, either a data structure or a physical file. That means physical file on disk where we are just storing the data. And each data store that is connected to a process by means of data flow symbols. That means this data store that is connected to a process by means of data data flow symbols. And the last thing, that is the output symbol, that the output symbol. So what is output symbol? That means is nothing but used by the hard copy is produced, right? That means output, what should be the produced? That means you can say, uh, you know you can say that is used when a hard copy is produced. That is the, you can say, about the output symbols. That means when you have to draw a DFD, you have to draw it by using this particular notations, right? This particular notation. One thing that you should notice, there is a concept which is useful, that is called data dictionary. That term we are using in the next class. So every DFD model of a system that must be accompanied accompanied by a data dictionary. And what is data dictionary? That lists all data items. A data dictionary actually lists all, you can say, data items that appear, you can say, in a DFD model, that appear in a DFD model. That means data item listed, it may be include the data flows and the content of all data store appearing on all the DFD in a DFD model. So actually, in the next class we will see that whenever we have to draw a DFD, first it will start from the zero level, that means the context diagram, and then one level DFD, two level DFD. That means actually what I am saying, It is a hierarchical procedure. What does it mean? That means first it's a very simple, but whenever we increase the level of DFD, it will make complicated. মানে আমরা একটা if we start with the library management system, আমি একটা লাইব্রেরি আছে, প্রথমে just I am taking a library and what are the different types of utilities. Then we can break like that. There should be librarian and there should be accountant who actually calculate how much books are purchased, and there should be some people who are entering their data through the software. There are lots of things are there. Then you have to break it into several components. That is the thing. That means we will start from the initially that is level 0 DFD, then 1 level DFD, then 2 level DFD, and so on, right? And when we go through one level to another level, the DFD will be complicated, right?